About algebraic operations are matrices, which are multiplication of a matrix by a scalar, addition or subtraction of two matrices, and multiplication of two matrices. First, we will see multiplication of a matrix by a scalar. So, multiplication of a matrix by scalar is nothing but we have to multiply the scalar with each and every elements of the matrices. More precisely, multiplication of a matrix by a scalar for a given matrix A equal to Aij of order m by n and a scalar k, we define a new matrix Ka which is equal to Bij whose order is the same one, that is m by n, where Bij equal to k times Aij for all ij. For example, if you consider a matrix A equal to A11, A12, so on A1n, A21, A22, so on A2n, and so on AM1, AM2, and so on AMN. Now, the scalar multiplication of the matrix is Ka equal to, we have to multiply each and every elements with K. So Ka11, Ka12, and so on Ka1n. Similarly, Ka21, Ka22, so on Ka2n. In the same way, K times AM1, K times AM2, so on K times AMN. So we have to multiply K with each and every elements of the matrix. That is the scalar multiplication of a matrix. Again, if we consider the another matrix B equal to like 2, 3, 4, 7, 8, 9, then this matrix order is 2 by 3 because there are 2 rows and 3 columns. So its order is 2 by 3. And so for example, 5A, 5B, 5B equal to, so multiply 5 with each and every elements of B. So 2 times 5, so 10, 15, 20, and then 35, 40, 45. So this is the scalar multiplication of a matrix. Next operation is addition or subtraction of two matrices. So addition and subtractions are component wise. That means consider two matrices of same order A and B. Then their sum denoted by A plus B and is again a matrix of same order obtained by adding the corresponding entries of A and B. More precisely, if A is a matrix Aij with order m by n and B is another matrix Bij of order m by n, then the sum A plus B is a matrix which is denoted by A plus B, which is equal to Cij, whose order is m by n, where Cij equal to Aij plus Bij for all ij. Similarly, if we consider example A and B, A equal to A11, A12, so on A1n, A21, A22, so on A2n. Similarly, AM1, AM2, so on AMN. And if you consider another matrix B, B equal to B11, B12, so on B1n, B21, B22, so on B2n, and so on BM1, BM2, and so on BMN. Note that their order should be same, then only the addition and subtraction is possible. Then A plus B equal to So you have to add the corresponding elements. That means you have to add first A11 and B11, then A12, B2, like that. So A11 plus B11, A12 plus B12, and so on. A1n plus B1n. Second row, A21 plus B21, A22 plus B22, and so on. A2n plus B2n. Finally, the last row in the same way, AM1 plus BM1, AM2 plus BM2, and so on. AMN plus BMN. For example, more precisely, if we consider the two matrices with numbers, that is C equal to 1, 2, 3, 7, 8, 9, and D is another matrix. So D equal to like 4, 5, 6, 3, 2, 1. Then C plus D. So C plus D is 1 plus 4, and then 2 plus 5, and 3 plus 6. So corresponding elements you have to add. 7 plus 3, 8 plus 2, then 9 plus 1. Simplify this. That is 5, 7, 9, and then 10, 10, 10. So this is sum of two matrices. In the same way, we can define the subtraction. If you consider the two matrices A and B of same order, here also, like addition or subtraction also, you should consider the same order matrix. Then A minus B is nothing but A plus minus 1 time B. So scalar multiple of minus 1 with B, and then add with A. Then that is A minus B equal to Dij, whose order is same, that is M by N, where Dij equal to Aij minus Bij. So you have to subtract the corresponding elements. So here itself, if you replace A by B, if you consider A and B are two matrices, these two matrices, then if you replace addition by subtraction, then you get the result. In the place of addition, you put subtraction. Then you get the subtraction of A and B. Okay. If you consider the same matrices C and D, then C minus D. C minus D equal to subtract the corresponding elements, that is 1 minus 4. 1 minus 4 is minus 3, and then 2 minus 5. So 2 minus 5 is minus 3, and 3 minus 6 is minus 3. And then 7 minus 3 is 4, 8 minus 2 is 6, then 9 minus 1 is 8. Next operation is multiplication of two matrices. The multiplication of two matrices is defined in the following way. That is, if you consider a matrix A is said to be conformable for multiplication with matrix B if the number of columns of A is equal to the number of rows of B. More precisely, if A equal to Aij, whose order is M by P, whose order is M by P, and B's order is P by N, then the product matrix AB, whose order is M by N. Note that A is a matrix of order M by P, and B is a matrix of order P by N. Okay, that means the number of columns of first matrix equal to the number of rows of the second matrix. Then only the matrix multiplication is possible, whose order is M by N. A's order is M by N. And the elements are defined like this: Cij equal to summation k equal to 1 to n Aik Bkj. That means Cij equal to AI1 B1J plus AI2 B2J and plus so on plus AIN BNJ. If you consider a numerical problem like A equal to so 1, 2, 3, 4, 5, 6 and this order is 2 by 3. Now consider the matrix B equal to like similarly you consider another matrix B like 3, 4, 5, 6, 1, 2. Then this is order is 3 by 2. Now the resultant matrix AB is a matrix of order 2 by 2. Okay, here the number of rows of first matrix is 2 and number of columns of the first matrix is 3, and here number of rows of second matrix is 3 and number of columns of second matrix is 2. Now here number of columns is equal to number of rows of second matrix, so the matrix multiplication is possible. This order is 2 by 2. AB's order is 2 by 2. Now multiply like this. Consider the first row of first matrix and first column of second matrix. Then the multiplication is defined like this: 1 into 3 plus 2 into 5 plus 3 into 1. Next element is consider the first row of first matrix and second column of second matrix. Then the matrix, then the second element is 1 into 4 plus 2 into 6 plus 3 into 2. Similarly, next element is getting by multiply the second row with of first matrix with first column of second matrix. That means 4 into 3 plus 5 into 5 plus 6 into 1. Finally, you multiply second row of first matrix and second column of first matrix. So 4 into 4. So this element with this element. So like that, next element and plus 5 into 6. These two. And then plus 6 into 2. This is the product of two matrices A and B. Now if you simplify, which is the resultant matrix, that is AB matrix. So this is the resultant matrix. Thank you.